Okay, so here is section 7.2, add and subtract rational expressions. So in this lesson, you will be adding and subtracting rational expressions. If P, Q, and R are polynomials where R does not equal 0, then P over R plus Q over R equals P plus Q over R. And P over R minus Q over R equals P minus Q over R. So, to add or subtract rational expressions with a common denominator, add or subtract the numerators and place the result over that common denominator. Okay, so that's what we have here, are those common denominators. You're just adding or subtracting the numerators and placing them over that common denominator. Always simplify rational expressions. Be sure to factor if possible after you subtract the numerators so you can identify any common factors. Also, we do not allow values that will make the denominator 0. Okay, so let's look at this example. Here, notice that our denominator is x plus 4, so x cannot equal negative 4 because that will make the denominator 0. Now we have that common denominator, so now all we have to do is go ahead and add those numerators. Okay, and then put that over that common denominator, which is the x plus 4. Okay, now I'm going to rewrite this numerator as x squared plus 11x plus 28, and put it over that x plus 4. Now let's go ahead and factor that trinomial because it is factorable. Okay, so we're thinking of two things that multiply to give us 28 and add to give us the 11. So that's going to be the 7 and 4. Okay, then we look to see if we have any common factors, and we do. We have the x plus 4, so that will cancel out. So that just leaves us then with x plus 7. Okay, so that expression simplifies to x plus 7, but the original expression here had a denominator of x plus 4. So x still cannot equal the negative 4. Okay, but here is our solution. Okay. All right, now, to add or subtract rational expressions whose denominators are opposites, what we're going to do is we are going to multiply one of the fractions by negative 1 over negative 1. Okay, so looking here, we almost have a common denominator. We just have those opposite signs. Okay, so I'm going to multiply one of the fractions by that negative 1 over negative 1. I'm going to choose to do the second fraction. Okay, so here I go. Okay, so now I have 7 over d plus I have negative 5 over positive d. So now I can add my numerators because I have the common denominator. So now I have 2 over d, and of course d cannot equal 0. All right, so let's go ahead and look at another one of those. Here we are subtracting. We almost have the same denominator, but they are opposites. So I just need to multiply one of the fractions by negative 1 over negative 1. So I'm going to multiply my second one by negative 1 over negative 1. So I get m squared minus 6m over m squared minus 1. Okay, so multiplying 3m by the negative 1, so that is a negative 3m, and then that positive 2 by negative 1, so that's going to be a minus 2. Okay, here my signs will change. So this is going to become a -1 plus m squared, or in other words, it just is that. You can rewrite it as m squared minus 1. So now I have the common denominator, and I can go ahead and subtract. Now, if you want to, you can go ahead and run that negative through there with your numerator. So now this becomes positive and we get the opposites here. So now that's going to be positive and that's going to be positive. Okay, so here I have m squared minus 6m plus 3m plus 2 over m squared minus 1. Then combining these like terms, I get m squared minus 3m plus 2 over m squared minus 1. All right, so now I'm trying to think of two things: to multiply to give me a positive 2 and add to give me -3. So I'm going to have m minus 2 times m minus 1. And then here I'm going to have m plus 1 when I factor that difference of two squares times m minus 1. All right, now I'm going to look to see if anything will cancel out, and we have that common factor, that binomial of m minus 1. Okay, so here I am left with m minus 2 over m plus 1. Okay, but don't forget here with this expression, we could not let m equal a positive 1 or a negative 1 because that's going to give us 0 in the denominator. Okay. All right, let's go ahead and do this subtraction problem. Here we already have a common denominator, so we can just go ahead and subtract. Okay, so I'm going to have 5x squared minus 4x squared, so that gives me x squared. Negative 7x minus x, that gives me minus 8x. 3 minus negative 9, so that gives me 3 plus 9, so I have 12 over the x squared minus 3x plus 18. All right, now I'm just going to go ahead and factor both trinomials. Okay, so I need two things that are going to multiply to give me a positive 12 and add to give me a negative 8. All right, so that's going to be a negative 6 and a negative 2. And then two things that are going to multiply to give me a positive 18, but then add to give me the negative 3. What is that going to be? We need both of our signs to be negative to multiply to give us a positive 18, and then to add to give us a negative. But there's not anything, so that's actually not factorable. Okay, so we are just going to have to leave it as is on that one. All right, now, what about if you don't have a common denominator, or they're not opposites to where you can easily just multiply by a -1 to get different denominators? Well, how to find the least common denominator of rational expressions. First, you're going to factor each denominator completely. List the factors of each denominator. Match factors vertically when possible. Bring down the columns, including all factors. Write the least common denominator as the product of the factors. All right, well, here we just have x minus 3 and x minus 2. So this is pretty easy, okay? You don't have to quite go through all those steps. There's nothing to factor, all right? We just know that we need an x minus 2 in this denominator, and we need an x minus 3 here. So I need to go ahead and multiply the numerator and denominator of this fraction by x minus 2, because whatever I do to the denominator, I have to do to the numerator. Okay? So so then over here, I'm missing that x minus 3. Okay, so I'm using the distributive property, and I get 3x minus 6 over that x minus 2 times x minus 3. Use the distributive property here, and I'm going to get 2x minus 6. Okay, so now I'm going to have the 3x plus 2x to get 5x, and a minus 6 and a minus 6 to get minus 12. Okay, and now we are done because you cannot factor this numerator. There is not a common factor to factor out, so that's going to be in simplest form. Once again, x cannot equal 2 or 3 because that would give us 0 in the denominator.